So today we'll back to the lesson. So again I'll teach you how to do indices, surd and logarithm. Let me do the recall for the chapter 4. Okay, so the topic that I want to discuss today is about this. Okay, so how are we going to solve this problem? Okay, copy the problem. Okay, first question. Okay, let's say we have a problem 2 3 power of n plus 4 3 power of n. Okay, what is the answer? Okay, express the following in terms of simplest form. That's the question. Okay, how are we going to answer this question? First, if you look at here carefully, this one is actually looking like, okay, if you look here, it actually looks like 2x plus 4x. You see, it's actually, you can put it this one as x. This one consider like x. So it's actually the question of 2x plus 4x. Because 3 power of n, okay, consider a constant. Is a variable. We put as a x. So here it's actually in terms of 2x plus 4x, we can say that is actually 6x. So we can do that. Actually what we can do here, okay, what we can do here is actually we can write here, okay, we can write here equal, okay, 2 3 power of n plus 4 3 power of n can be put as 6 3 power of n. So that is the answer. So we can write that the power, the multiplication of the something power, we can add this to become 6 3 power of n. So we can put it as a single answer. Okay, now your turn. Okay, now your turn. Come, answer this question. Number 2, I want you to answer 2 power of n plus 2n plus 2. So how are you going to write this answer? How are you going to simplify this answer? So now I go to the answer. Okay, you see, now the problem is, okay, what is the x? You must think what can be the, what you can put as x. Okay, let's say we have, let's say we have x, we put as 2n. Okay, so I consider this one as like x. Okay, I consider this is x, but the problem is I have plus 2. So now what are you going to do? We're going to separate this plus 2, okay, become times. Okay, this one is plus 2. Okay, I'm going to use this formula. Remember, we have this formula am times an. We can write that as am plus n. It's a indices formula one. So when we have a plus, we can break them into two. One is am and an. Okay, so here you can write that equal, okay, 2n plus, okay, so 2n plus 2. So you break them become what? 2n times 2 power of 2, right? Because this one consider the m and n. Okay, this one is consider the m and n. This one is m, this one is n. So I break them. I put this 2n times 2 power of 2. Okay, then what I'm going to do is I'm going to write this as this form: 2n, okay, plus 2 power of 2 become 4. So 4 times 2n, we can write that as 4 times 2 power of n. You see, now I change, okay, I change the 2 power of 2 become number, then I put bracket here so that I can see this as a x, okay, a form of x. So I can easily plus these 2. Okay, again, Okay, again, I remind you again. Okay, I put earlier I put this is x. So this is x, and again this is x. So it's actually x plus 4x. You see, it's a problem of x plus 4x. So what you can write here? You can write that equal. So x plus 4x become 5 and 2 power of n. Okay, try this question. Number 3. Copy the question. 3n plus 3 minus 3n plus 2 and then minus 3n plus 1. Try this question. As I said to you, okay, put x. Okay, you must find what is your x. Okay, let's say we put x equals to what? 3n. The rest you must take out from the n. Okay, for example, the 3 here you must split from the n. This 2 you must split from the n. This one again, the 1 you must take out from the n. Then only you can proceed for the next stage. Equal. Okay, what do we get? We'll get, okay, again, what formula? I'll use this formula. am times an must be equal am plus n. So we break into 2, m plus n. Okay, I'll get what? I will get 3n times 3 power of 3 minus 3n times 3 power of 2 minus 3n times 3 power of 1. Okay, so we just rearrange everything. 3 power of 3 become 27. 27 in bracket 3 power of n minus, then what? 3 power of 2 become what? 3 power of 2 become 9. 9 times 3 power of n minus, and 3 power of 1 become 3, and then 3 power of n again. Okay, this one is 12. Oh, it's supposed to be 15 lah. 12 is 15 lah. 15, because 27 minus by 12 is 15. I go for next question. Okay, I give you another chance where you can try one more question. Okay, let me try this question. Number 4. Okay, number 4, the question is 5n plus 1 minus 5n and then minus 5n minus 1. Okay, remember we have this formula. am times an equal am plus n. am divide an equal am minus n. So we have this. What happened here? Okay, so we'll get what? Equal. Okay, so n plus 1. Okay, we can easily put it. N times by 5 1. Okay, 5 power of n times 5 power of 1 minus, then 5 power of n minus 5 power of n, and then we can put divide. But here I'm not going to put divide. I put times, but I put negative 1 here. Can also, actually you put divide also can, you put minus, divide also can, and then times also can, but I prefer times because I want to convert it become 1 over 5. Okay, because when you have something like power of negative 1, we can write that as x 1 over x. So I'm going to change in the fraction form. Okay, I still put divided because the minus I want to give it to the second 5. Can. Okay, you can put divide, you can put times, but I prefer go for times. Okay, what is next? Next, 5 power of 1 become 5. So 5 times 5n minus, and then 5n minus. Okay, how are you going to write this? Okay, remember I told you here. Okay, remember this 1 over, okay, anything power of -1, okay, a value power of -1, we can write that as 1 over x. Okay, remember you have meter per second. Meter per second is actually what? Meter per second. So something -1. -1 is sitting down lah. Is a denominator here. So I can put here 1 over 5 times 5 power of n. Okay, 1 over 5 times 5 power of n. Okay, now I'm going to minus all. Okay, what is this actually? 5 minus what value? This one supposed to be 1 lah. Okay, this one supposed to be 1. So I can put 1 here also. Okay, easy for me to recognize the value. I can put here 1. Can lah, you can put 1 so that you can see the numbers clearly. So 5 minus 1 become 4. 4 5 power of n minus 1 over 5 5 power of n. So 4 minus 1 over 5 become 3 4 over 5 means I'll get 3 4 over 5 means 19 over 5 lah. So this is the answer. Next I'll give you this. Okay, copy the question. Okay, number 5. Okay, number 5. Prove that 3 power of n plus 1 plus 3n plus 2 is a multiple of 4. That's a question. Prove that 3n plus 1 plus 3n plus 2 is a multiple of 4. How are we going to answer this question? Okay, give a try. How are you going to answer this question? Okay, what do you mean by multiple of 4? That is the basic things you should know. What do you mean by multiple of 4? Multiple of 4 means, okay, you can divide by 4. Okay, if you find something for this number, let's say you do something with the number here, this one, when you do something, it can be divided by 4. That what we call as multiple of 4. Okay, so let me give you the hint so that you can proceed. First, what you need to do is you need to plus these two. 3n plus 1 plus 3n plus 2. You must do something so that you can simplify them. Okay, how are you going to simplify them? Remember, we have this again. am times an equals to am plus n. Okay, so go here, you'll get 3n times 3 power of 1 plus 3n times 3 power of 2. Okay, so what do you get here? You'll get 3 power of n plus 3 power of 2 is 9, 3 power of n. So 3 plus 9 is actually 12 3 power of n. Okay, now, okay, is it we already answered the question? Not yet, okay. Okay, we need to say that something to the multiple of 4. So 12 3 power of n is a multiple of 4. Okay, why? Okay, why? Why? Because 12 3 power of n can be divided by 4 1. So when you divide, you get 3 here. So it's actually, you get a whole number, you can completely divide. So it should be a multiple of 4. So it's acceptable. Yes, it is a multiple of 4. Okay, what I mean, when you divide this number with 4, it's actually divide completely. So divide completely means it's a multiple of 4. Okay, that is about the question. So we already proved it's a multiple of 4. How you prove? Then you write this. So you divide, you show this. So it's actually completely divide. Then it's a proven. Okay, we go for the another question. Okay, question number 6. Show that two n plus 2 plus 2n plus 4 is a multiple of 5. Okay, this is a question. Again, remember, multiple of 5, meaning that when you simplify this, the number should be something related to 5. Try to simplify this. Okay, so once you see, okay, if you see, you'll get 2n times 2 power of 2 plus 2n times 2 power of 4. So 2 power of 2 become 4 times 2n plus, and then 2 power of 4 become 16 2n, then 4 plus 16 become 22n. Okay, so definitely 22n is a multiple, must be a multiple of 5. Is confirmed. It's confirmed, must be a multiple of 5. Why can be multiple of 5? Because can be divided by 5. So when I cancel, I get 4. So I get 4 to power of n. So it's a completely can be divided by 5. So it's acceptable. So definitely we have already completed the proven. So this is the proving case for this question. Okay, want to try another question? Okay, I think I can give you one more question. Okay, number 7. Okay, go for question number 7. Prove that, okay, 5n plus 2 minus 2 5n then plus 5n plus 1 is divisible by 4. Okay, the question, divisible by 4. Again, try the same thing. So divisible or multiple, all same thing only. Only the words are different, but they are actually going for okay, they must be something, must be related to 4. Okay, how are you going to do? Okay, first step, 5n plus 2 minus 5n plus 5n plus 1 question. Copy the question. So now I'm going to break them. So 5n times 5 power of 2 minus 2 5n plus 5n times 5 power of 1. Okay, what do you get here? So 5 square become 25. So you get 25 5n minus, and then 2 5n, and then plus 5 power of 1 is 5 power of n. Okay, so what will you get? The last answer, 25 plus 5 is 30. 30 minus 2 is 28. So this one is supposed to be 28 5 power of n. Okay, is it divisible by 4? Yes, of course, because 28 can be divided by 4. Okay, 28 5n is a multiple of 4. Okay, multiple of 4, so definitely can. So multiple of 4 can be divided by 4. So because divide, you can divide. Sorry, this is not 4. This is n. Okay, this is n. Divide by 4. So it's actually what you get. 1 this one 7. So you divide completely. So it's a confirm is a divisible by 4. Okay. Okay, now I will go for the next section. Okay, now I'm going to go for the law of surds. Now I'll go for the law of surd. Okay, some books they use surd, some they use surds, but I think surds works very better. Okay, what do you mean by surd? Surd is actually square root of 2. Okay, it's actually, let's say I put m here, it's actually what? It's actually square root of 2. Okay, we prefer 2. We put 2. Okay, surds is a special name for the square root of 2. Okay, but 2 here, okay, remember the 2 here and this 2 here is totally different. Okay, this 2 is different. This one is something like 2 times by square root of m, but this is actually square root 2 of m. Remember, the 2 small is actually showing that the root of the square, root of the root of the square, not root of the what number. Okay, it's actually can be root of 3 also. You put 3, you get root of 3. You put 4, then it's become a root of 4. Okay, root square is 2. Square is 2. So root square, so it's actually root square. So root power of 3, root power of 4. But this 2 here is different. It's actually 2 times 2m. So you must know how to differentiate these two. 2 times and then square root. So 2 things you must consider before you go for the law of roots. Okay, first I want to teach you about the simple things so that you can go further. Okay, first, let's say we have a number. Okay, I delete this. Okay, let's say we have a number. Okay, a number called 16. Okay, I put 16, square root 16. Okay, what is the answer? So you get 4. Okay, because anything easy to go. 1 square, 2 square, 3 square, 4 square, 5 square, and so on. We call this as a perfect square number. Perfect square numbers. Okay, these are all perfect square numbers. Why we call as a perfect square numbers? Because when you get this number, let's say 1, 4, 9, 16. Okay, this one, all this number, when you do square root, you put square root 1, you get 1, because the reverse process is actually 1. Okay, so when you put 4, then you get 2. So that's why we call this as a special name. So all these numbers are is actually perfect square number. I think your syllabus have this. So I just recall these things perfect square number. So when you do square root, you get back whole number. Okay, so that is about the first thing you must know, the introduction for the roots. Okay, now back to the number. Let's say I have this number. Okay, again I go for 16. Okay, actually what I can do is I can break them also. I can break them. For example, I can put there 4 times by 4. I also allowed it to do this. Okay, square root 16, I can write that as square root 4 times 4. 4 times 4 is actually what? 16. What? So now what I'm going to do, I'm going to break some more times square root 4. You see, the square root I can break only if I have times here. Okay, I want you to jot down this. Okay, I want you to jot down this. We can break the square root if we have a plus here. Okay, so what do you get here? Square root 4, you'll get 2, and then square root 4, you get 2. So 2 times 2, you get 4. So it's actually allowed. You can do this. Okay, you can do this. Okay, come copy this first. Okay, I give you another example where you cannot do this, the same as this. Okay, copy that. Okay, now I want you give this. Okay, I want to give you this. Okay, let's say I give you square root of 32. Okay, now I want to convert it to square root form. Okay, it's a square root. How I'm going to put it in the simplest form? Okay, so first thing you need to know is 32. You see, back to here, 32. Okay, what number? Okay, what number here? 1. Okay, okay, I think I need more space. Okay, let me put here. Okay, what number? Let's say I take all the perfect number. 1, 4, 9, 16, 25, 36, and so on. Where I get this number? 1 square, 2 square, 3 square, 4 square, 5 square, and 6 square, and so on. Okay, again, 1 square. I write it here. 1 again. 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and so on. Okay, that's why you get this number. What number here? Okay, what number here can divide by 32? Okay, so definitely 1 is the simplest number we have. Always can lah, but we must go for another number, not 1 lah, because 1 is always can. We go check another number. Okay, I divide by 4. Can write 32 can be divided by 4. What do you get? You get is 8. Yes, you are right. Okay, now, okay, of course 9 cannot lah. Then we check another number. So 32 divided by 16. So 16 you get what? 16 you get 2, right? So can also. Then after that 25 is bigger, right? So after that all cannot. Okay, the number that I'm going to choose here is 16. So we must go for the largest number. So which means I'll choose 16. So when I choose 16, meaning that I'm going to write this. I'm going to write square root. Okay, so I can type. Okay, I'll write 16 because can be divided by 16. So 16 times what? You get 32. So it means 16 times 2. Right? Okay, so here what I can say here is actually what you can do here, 16, and then you can break them into square root 16 and then square root 2. Okay, now square root 16 you'll get what? Square root 16 you'll get 4. 4 square root 2. So we already found the answer. So this is what we call as the simplest form of the simplify in the surd form. Okay, simplify in the surd form. So we already convert the square root 32 in the simplest form, which means we can also write that as 4 square root 2. Okay, now your turn. Okay, I give you a question. So you try this time. Okay, so your turn. So that you try square root of 52. Yeah, square root of 52. Again, you do same thing. 1, 4, 9, 16, 25, 36, and so on. Check the most biggest number, the largest number that which can be divided by 52. So when you press calculator, okay, 52 divided by 16. Okay, you get decimal. Okay, 52 divided by 36, you get decimal. 52 divided by 4. Okay, I think only 4 is working, right? Okay, only 4 is working. So 52 divided by 4, you get 13. When you divide with 16, 15, this one you get 3 point something, right? 3.25. 52 divided by 16, you'll get 3.25, which mean, okay, it is cannot be lah, because we need to get whole number. So this one cannot lah. So 16 not work for here. So only the largest number that works here is 4. So what are you going to do? Again, square root. Okay, so 4 times 13. We put 4 times 13, because 4 times 13 you get 52. And then from there you split the square root. So square root of 4 times square root of 13. Okay, and then definitely square root of 4 is what? Square root of 4 is 2, and then square root of 13. So we get the answer. Okay, we try one more. Okay, another question. Okay, now I give you one more question, which is 45, square root 45. Try this. So definitely this one is a even odd number, so definitely it won't works for 4 lah. So we try 9 definitely can lah. So it's actually 9 5 lah. Okay, so when you do the splitting, so you get square root 9 times square root 5. Square root 9 is 3, and then square root 5. So this is the root form of the for root 45. Okay, so I give you one challenging question. Okay, this one is easy, huh? Now I give you one challenging question. Okay, let me try this. Okay, so 2 square root 50 minus 3 square root 2. You need to simplify to the simplest form. Okay, so now I give you answer, huh? Okay, first 50 divided by 4. Okay, this one not a whole number. 50 divided by 9, also not a whole number. 50 divided by 16, not a whole number, but 50 can be divided by 25, so this one works. Okay, so we divide, you get 2, right? This one you get 2. Okay, which means that I can write here equal to square root 25 times 2 minus 3 square root 2. Okay, so what do you get here? You'll get equal, then 2, we put a bracket. Okay, so this one 25, we can put it as a square root 25 times square root 2 minus 3 square root 2. Okay, we do everything together now. Means whatever we learned just the previously, we use back again for this question. Okay, now what you get here? Square root 25 become 5. So 2, 5 times square root 2 minus 3 square root 2. Okay, so 2 here, okay, in bracket means it's a multiplication. So 2 times 5 we get 10. So 10 square root 2 minus 3 square root 2. Remember just now I said to you, consider this like x. Okay, treat the square root like x. Treat this as a x. So easy to see. So actually 10x minus 3x. Okay, you are very good here in this. Okay, x, y, z, all you are very good. Now you must see the square root as a x, the form of x. So you easily can see the things. So you get what? So you get 7x. Same applied here. So you can put it here equal 7 square root 2. Okay, so I have 4 square root 27 plus 2 square root 3. Give me the simplest form. Okay, definitely something related to 9. Okay, because okay, must be only can divide by 9 because it's an odd number word. Okay, so 27 divided by 9 you will get 3 Okay, so means 4 bracket square root 9 times 3 plus then 2 square root 3. Okay, you will get here 4 times, so here you will get square root 9 times square root 3 plus and then 2 square root 3. Okay, here square root 9 is actually what? Square root 9 is actually 3. So you can convert it as 3. So 3 square root 3 plus 2 square root of 3. Okay, so 4 times 3 you get 12. So 12 square root 3 plus 2 square root 3. So you can easily see here. So 12 plus 2 become 14. 14 square root of 3. Good.